Hello, my name is Mukiming AE230074, and now I am going to present about the introduction of our project. DC motors are essentially components in many electrical and mechanical systems as they transform electrical energy from a direct current source into mechanical rotation. These motors are commonly found in everyday appliances, industrial automation system, and electrical vehicle. Among the type of DC motor, permanent magnet and separately excite design are popular due to their simplicity and controllability. The working principle of a DC motor is based on electric magnetic theory. According to Lorentz law, when electrical current flow through the conductor in magnetic field, a force is produced that causes rotational motion. This motion generates a back electromotive force or back EMF, which opposes the appliance voltage and help regulate the motor speed and efficiency. Thank you, and I will pass the next part to my partner.
I'll be explaining the design and construction of our project. We demonstrate motion using electromagnetic force with simple, low-cost materials. The goal of this project is to build a basic DC motor that shows how current and magnetic fields can produce motion. A core principle in electromagnetism. We use everyday items including copper wire that function as the coil to carry electric current, magnets to provide the magnetic field necessary for motor action, paper clips and wood act as a stand and support frame. Battery supplies the DC voltage to power the system, and tape holds the components in place. These materials not only make the project affordable, but also help us understand the working principle clearly. With proper placement and support, this interaction produces rotational motion. A simple commutator effect is achieved by carefully scraping part of the wire, allowing intermittent contact and continuous rotation. Let me explain how we built it. We started by cutting an 8 to 9 cm wooden dowel, which acts as the rotor shaft. Then we drill 1 mm holes at both ends to allow smooth rotation. Next, we attach wooden coil holders that is 25 by 10 mm and stabilizers about 18 mm to the shaft. Each holder was wound with 50 to 100 turns of copper wire to form the coils. At the ends of the wire, we scrap the insulation on one side only. This created a simple commutator, allowing the current to flow in one direction and support continuous rotation. The rotor was supported using bent paper clips, which also acted as brushes. These were fixed to a wooden base, making sure they touch the coil ends properly. We then placed magnets on both sides of the coil, aligned in a way that created a balanced magnetic field around the rotor. When we applied DC voltage, current flowed into the coil, and the interaction between the electric current and magnetic field produced electromagnetic force which made the rotor spin. This project helped us visualize how a motor works that is transforming electrical energy into mechanical motion through simple electromagnetic principles.
Hello, my name is Alifata bin Ali, and I will present about the software solution that we use for this project. So we use a simulating model of a DC motor system which do in assess its mechanical and electrical behavior prior. So we use the armature resistance and inductance which is presented for a series resistor and inductor. We also added a current sensor which is placed in series to measure the armature current. To simulate the display value, we will use PS simulating converter to transform all physical signal and connected to display block and parameter that could be tracked. The solution was set up to precisely capture the system transient reaction using a continuous step time. This model forecasts the motor's behavior under specific given mechanical parameter, load torque, and input voltage.
Okay. Các bạn
So this is the result for testing the simulation. So the simulating circuit shown is a closed-loop DC motor control system designed to regulate the motor speed. On the left side, the DC voltage source supply power through an inductor and resistor, which model the motor's armature inductance and resistance. The current flowing into the motor is measured using an ammeter probe, which provides real-time current values during simulation. The green section on the right represents the motor and its control system. The motor speed is measured by a speed sensor, and this measured speed is feedback into a comparator block where it is compared with a predefined reference speed. The error between the actual and desired speed is processed by a controller. Logical blocks such as AND gate help manage the signal flow and enable or disable motor operation based on specific conditions. Display blocks show the real-time speed, which is 13.91 radian per second, and current of 5 amp in simulation. The circuit simulates the dynamic behavior of a DC motor under closed-loop speed control, highlighting the interaction between electrical input, controller response, and mechanical output.
Hi, I'm Joshua Lim. My lecture number is AE230065. So I will present the discussions of our group project. Basically, our group project have few issues. The first problem is the friction in paperclip bearing and imperfect magnetic alignment reduce the rotation speed. So the rotation speed we measure at that time is lower than the expected value because it has friction that slow down its rotation. And brush contact resistance fluctuation caused by wiring tension and enamel residue on the commutator also slow it down. Extra weight from material like duct tape also increase the torque demand. So the recommendation is use ball bearing instead of drilling hole in the shaft to reduce friction, and also can improve fabrication precision and material choice to enhance performance and efficiency. So you should use lighter material because lighter material will reduce the required torque to turn the shaft. So in this project, what we learn is the combination of simulation and physical testing efficiency reinforce theoretical concept such as Rowland force, back EMF, and so on. And we also highlight the real-world challenge in building functional electromechanical system.
Hi, Assalamualaikum. My name is Muhammad Nur Aiman Berosnan. My metric number is CE240037. Now we're talking about conclusion for this project. Alright, this project successfully demonstrates the fundamental principle of a DC motor by constructing a working prototype and analyzing its performance. Despite encountering initial challenge with coil rotation stability, the troubleshooting process highlighted critical design elements such as proper commutation, consistent magnetic field alignment, and the minimization of mechanical friction. Ultimately, the experiment provided valuable hands-on experience, bridging theoretical understanding with practical application in the design and assessment of the electromechanical system. Alright, that's all for our project. Thank you.
First thing first is take a wood trowel and drill a bit around 1 mm in diameter. Make a hole in the center of the trowel. The hole must go about in 1 cm in depth. Make the hole in the both sides. The next is take a wood stick and cut it into two pieces, which is 25 mm in length and 10 mm in wide. Then glue them to the wood trowel at a distance of 20 mm from one of the ends. Okay, you should get like this, and then glue the other side. So the part of our rotor is almost ready. Now take the coil and give the coil around 15 cm free and wind one coil at one of the sides. Don't forget to wind between 15 and 100 turns. After finish, move to the other side and continue winding in the same direction wind and the same number of turns as you did. Now take the two wires that are coming from coils. Remember, wires are not aligned. They are at angle of between 20 and 30 degrees. Now we have to make the commutator. Remember that you have to remove the varnish from the magnet wire to make electrical contact. Remove the varnish for the both sides. So our rotor is ready. Now we have to make stand for the rotor. I'm using the polystyrene block and paper clip. After finish do the stand for the rotor, your prototype will look like this. If the rotor can move easily, so you are doing well. Now we have to make stand for the magnet. I use a wood stick and put it into left and right of the rotor. The next step is to install a couple of bushes to make contact with the commutator. So it will look like this. Now our motor is ready for work, so you can try it.
Okay. Come on.